Alright, let's go. Number 10. The WOW signal. The signal that arrived once, at exactly the frequency it should have, and never came back. On the night of August 15, 1977, a radio astronomer named Jerry Eman was reviewing computer printouts from the Big Ear radio telescope at Ohio State University. Big Ear was scanning a patch of sky in the constellation Sagittarius, listening at 1420 MHz. That number matters. 1420 MHz is the natural emission frequency of neutral hydrogen, the most abundant element in the universe. Any intelligent civilization trying to make itself heard across interstellar distances would almost certainly broadcast on or near that frequency, because they would know that we would be listening there. At 10:16 p.m. Eastern Time, Big Ear caught something. For 72 seconds, the exact length of time the telescope's fixed beam could remain pointed at any single spot in the sky as the Earth rotated, a signal poured in. It was 30 times louder than the background cosmic noise. It was narrowband, meaning it occupied a single precise frequency, which almost no natural cosmic process produces. And it rose and fell in intensity in exactly the pattern a genuine sky source would produce as it drifted through the beam. Eamon circled the string of numbers on the printout in red ink and wrote a single word beside it. Wow. Then it stopped, and it never, in the nearly 50 years since, has come back. The Big Ear team pointed the telescope at that same patch of sky the following night. Nothing. They pointed it again the night after that. Nothing. Over the following decades, larger and more sensitive telescopes, the Very Large Array, Arecibo before its collapse, the Green Bank Telescope, have searched the same coordinates dozens of times. The sky at that location, at that frequency, has stayed silent. Every proposed natural explanation has been examined and so far dismissed. It was not a satellite, because satellites are not permitted to transmit on the hydrogen line, and none were in the correct position. It was not a reflection from Earth, because the signal's frequency drift matches an object outside the atmosphere. It was not a comet's hydrogen cloud, an explanation that briefly circulated in 2017 and was quietly retracted when the numbers did not match. And the most disturbing detail is this. The signal was so clean, so narrow, so precisely tuned to the frequency an intelligent species would choose to be heard, that when Eamon himself was interviewed decades later, he refused to rule out artificial origin. He simply said that a single, unrepeated data point is not enough to publish a conclusion. And so the WOW signal sits in the SETI archive, uncategorized, unexplained, and unrepeated, a 72-second question that nobody has ever answered. Number 9. The Lorimer Burst, the 1 millisecond flash of energy that broke a telescope's understanding of physics. In 2007, a graduate student named David Narkovich was working through 6-year-old archival data from the Parkes Radio Telescope in Australia, hunting for pulsars. He was looking through recordings from 2001 that had never been analyzed in detail, and on August 24th of that year, at a specific moment, he found something the telescope had recorded and no human had noticed. For a single millisecond, 1,000th of a second, a burst of radio waves had swept across every frequency the telescope could detect. It was not periodic like a pulsar. It was not a supernova signature. It was a single, sharp, colossal flash, and then absolute silence. When his supervisor Duncan Lorimer helped calculate the burst's origin, the numbers were absurd. Whatever had produced it was 3 billion light-years away, and for that flash to reach Parkes with the intensity it had, the source had released in 1 millisecond more energy than the sun releases in an entire month. Nothing physicists knew about could produce that. Not a colliding neutron star, not a hypernova, not an evaporating black hole. The energies were too extreme, the duration too short, the location too far from any known galaxy. For 6 years, the Lorimer Burst was assumed to be an instrument error. Then in 2013, telescopes started detecting more of them. They now have a name, Fast Radio Bursts, or FRBs, and hundreds have been recorded. But the original one, the Lorimer Burst, remains among the strangest, and the mechanism producing them is still officially unresolved. Some of the FRBs, we will see shortly, do things that no natural process should be able to do. And they all began with a single millisecond, missed by a computer, buried in an archive, sitting on a hard drive in Australia for 6 years, waiting to be found. Number 8. FRB 121102. The fast radio burst that repeats, and no one knows how, or why, or from what. Most fast radio bursts arrive once, burn brighter for a millisecond than 100 million suns, and never repeat. But in November 2012, the Arecibo Observatory in Puerto Rico picked up a burst from a very small dwarf galaxy, roughly 3 billion light-years away. It was catalogued as FRB 121102, and at the time seemed to be like all the others. Then in 2015, it happened again, from exactly the same coordinates. Then again, and again, and again. By 2019, FRB 121102 had produced hundreds of bursts, all from the same location, all with distinct characteristics that ruled out most single-event explanations like colliding stars or one-time cataclysms. Whatever was producing these bursts was surviving them and doing it repeatedly. Then in 2020, astronomers noticed something even stranger. The bursts were arriving in a rough 157-day cycle, not random, not continuous, patterned. Something at those coordinates was flaring in a rhythm that looked almost orbital. Every proposed source has struggled. A magnetar, the ultra-magnetized corpse of an extremely massive star, is the leading candidate, but no known magnetar behaves this way, and no magnetar we have observed in our own galaxy repeats on a 157-day cycle. A neutron star orbiting a black hole and being periodically disturbed has been proposed, but the observed energies do not fit any orbital model. And the most unsettling detail is that FRB 121102 is not the only one anymore. Dozens of repeating fast radio bursts have now been cataloged, some with even stranger periodicities. In every single case, physicists can describe what is happening but not why. The bursts arrive on schedule. The schedule fits no known physical clock. And out at those coordinates, 3 billion light-years away, something is still flashing right now, exactly as it always has, waiting for us to figure out what it is. Number 7. BLC-1, the narrowband signal that arrived from the nearest star to Earth and disappeared before it could be repeated. In April and May of 2019, the Parkes Radio Telescope in Australia was participating in the Breakthrough Listen initiative, one of the largest scientifically funded searches for extraterrestrial intelligence ever conducted. It was pointed at Proxima Centauri, the closest star to our Sun, only about 4 light-years away. Proxima Centauri has at least 2 known planets, and one of them, Proxima b, is inside its star's habitable zone. The observation was routine. It was supposed to be background data, but when the recordings were analyzed a year later, they contained something no one expected. A narrowband radio signal at 982 MHz, drifting in frequency in exactly the way a signal from a moving planet would drift, appearing only when the telescope was pointed at Proxima Centauri and vanishing when it was pointed anywhere else. The signal was catalogued as Breakthrough Listen Candidate 1, or BLC-1, and for months the analysts kept it quiet because the implications were serious. It was narrowband, which almost never occurs naturally. It was pointed, it corresponded to a real star system with real planets, and it fit the profile of exactly the kind of signal SETI has been looking for since the 1960s. In the end, the Breakthrough Listen team published their analysis in October 2021 and concluded that BLC-1 was almost certainly interference from human technology on Earth, possibly a piece of malfunctioning equipment or a stray transmission from a device the team could not identify. Case closed, officially. But if you read the paper carefully, the language is more cautious than the press coverage suggested. The team was unable to identify the specific source of the interference. They ruled out most Earth-based candidates, but not all. And the signal's characteristics, its frequency drift, its coincidence with Proxima Centauri observations, its narrowband precision, remain a match for what a genuine detection would look like. BLC-1 has never been redetected. Whatever produced it, on Earth or elsewhere, does not appear to be producing it anymore. And that, for a certain kind of astronomer, is exactly the problem. Number 6. Tabby's star, the star that dims in patterns nothing in nature is supposed to produce. In 2015, a team of citizen scientists working with data from NASA's Kepler Space Telescope flagged something bizarre. A star roughly 1,470 light-years from Earth, formerly called KIC 8462852 and informally nicknamed Tabby's star, was doing something no other star Kepler had observed was doing. It was dimming, sometimes by 20%. Sometimes for weeks at a time, in patterns that had no periodicity, no obvious cause, and no known analog anywhere else in the sky. For context, when a planet passes in front of its star from our line of sight, the star dims by a fraction of a percent, briefly and regularly. A Jupiter-sized planet in front of a Sun-sized star produces about a 1% dip. Tabby's star was dropping by 20%, sometimes more. Whatever was passing in front of it was enormous, or there were vast numbers of objects, or the star itself was doing something no other star had been caught doing. The initial media coverage, in 2016, seized on a proposal from astronomer Jason Wright at Penn State. He noted, carefully and honestly, that the dimming pattern could not be ruled out as consistent with what a Dyson sphere or Dyson swarm might look like, a hypothetical megastructure built by an advanced civilization to harvest a large fraction of a star's energy. Wright never said it was aliens. He said that it was one of the very few candidates that fit the data, and that it should be investigated. Since then, the leading natural explanation has become a swarm of dust and debris orbiting the star, possibly from a shattered planet or a passing cometary field. Follow-up observations in infrared support this to a degree, but the exact pattern of dimming still resists a clean fit. The dust theory explains the general behavior, but not every individual dip, and no other star observed by Kepler, and now by TESS, has ever done exactly what KIC 8462852 does. The star is still being watched. It is still dimming occasionally, in ways that surprise the astronomers watching it. And every few years, someone publishes a paper reminding the community that the Dyson swarm hypothesis has not been formally excluded. It has only become unfashionable to say out loud. Number 5. The Nançay Blip. The other signal from 1977 that nobody talks about, because we still cannot explain how it got here. Everyone knows the WOW signal. Almost nobody remembers that the year 1977 produced a second unexplained radio detection, and that this one arrived at a completely different frequency, from a completely different observatory, and has been sitting in the archive ever since. In June of 1977, roughly 2 months before the WOW signal, the Nançay Radio Observatory in France was conducting a survey of the sky at 21 centimeters, the hydrogen line, the same frequency Big Ear was scanning. Buried in the survey data is a narrowband transient that lasted several seconds from a patch of sky that has since produced nothing. The detection was noted in an internal report, but never published as a major finding. This was partly because the observatory did not have a full backup team on that shift, partly because the second-look observations produced nothing, and partly because 1977 was a very early year for taking transient detections seriously. Astronomers had not yet grown accustomed to the idea that the universe could produce signals that never repeat. The Nançay Burst, as it is informally called by the small number of researchers who know about it, has been re-examined in the last decade. It is real. It is narrowband. It is not explained by any known natural mechanism, and it is not consistent with any identified Earth-based interference from that era. What it is, exactly, remains open. The disturbing pattern is that if you go back through the archives of major radio observatories from the 1970s and 1980s, a time before digital recording became universal, before every observation was automatically saved, you find scattered notes in observation logs and internal memos referring to brief unexplained signals that were noted, checked once, and then filed away. The Nançay Blip is one of them. Others exist. Some are lost forever because the tapes have degraded or been recorded over. We do not know how many signals we have missed. We only know that the ones we did not miss keep pointing at the same conclusion. Something out there talks, or does something that looks like talking, and we hear it just often enough to know we are not imagining it. Number 4. The HD 164595 signal. The signal that a Russian observatory hid for over a year before quietly announcing it, and then quietly walking it back. In May of 2015, the Ratan 600 radio telescope in the Karachay-Cherkess Republic of Russia detected a strong signal from the direction of HD 164595, a sun-like star roughly 95 light-years from Earth. HD 164595 has at least one confirmed planet, a Neptune-mass world, and its overall stellar properties are close enough to the Sun's that it has been repeatedly flagged by SETI as a target of interest. The Ratan 600 signal was at a frequency of 11 GHz. Its strength was significant, and the Russian team, for reasons that were later criticized by the international astronomy community, did not tell anyone about it for more than a year. The detection was quietly presented at a conference in the summer of 2016, and only then did the wider world find out. When Western astronomers heard about it, several major observatories, Allen Telescope Array in California, Green Bank in West Virginia, immediately repointed at HD 164595. They saw nothing. The signal did not repeat. The Russian team, under pressure, eventually offered a mundane explanation. They suggested the signal was probably terrestrial interference, most likely from a Russian military satellite operating in a frequency band that overlapped with their receiver during that particular observation. But that explanation has never been formally confirmed. No specific satellite has been named. No orbital match has been published. The signal, whatever it was, remains catalogued as unexplained, and the fact that a professional observatory sat on the data for over a year before disclosing it has itself become a subject of quiet controversy within the SETI community. HD 164595, meanwhile, still has its planet, and the search continues. And the question of what a modern radio observatory would do if they did detect something that they were confident was artificial, how quickly they would tell the world, how much they would verify first, whether they would tell the world at all, is one that the Ratan 600 incident answered in the least reassuring way possible. Number 3. ASKAP J173608. The object at the center of our galaxy that behaves like nothing else in the observed universe. In 2021, the Australian Square Kilometre Array Pathfinder, ASKAP, detected a repeating radio source near the center of the Milky Way. It was catalogued as ASKAP J173608.2-32165. And unlike a fast radio burst, unlike a pulsar, unlike any known transient, it did things that no proposed source matched. It appeared, it vanished, it reappeared weeks or months later. It was polarized in a way that no ordinary neutron star produces. It never repeated on a fixed cycle. And when it turned on, its brightness could rise by a factor of 100 within a single day and drop back down just as fast. The team that discovered it, led by Ziteng Wang at the University of Sydney, went through every known category of radio source in the astrophysical literature and could not find a match. Pulsars do not behave this way. Magnetars come closer, but no known magnetar has been observed with this specific combination of polarization, brightness variability, and irregular on-off cycle. Star formation regions do not produce this polarization. Ordinary supernova remnants do not vary on these timescales. In the paper, the authors described ASKAP J173608 as belonging to a new class of unknown objects. The disturbing implication is that our census of the galactic center, the region within which we live, is nowhere near complete. Something is sitting at or near the center of the Milky Way, 30,000 light-years from where you are right now, producing radio signals that no known object should produce. And it appears to have been doing so for at least the entire time we have had radio telescopes sensitive enough to detect it. ASKAP has since flagged several more objects with similar characteristics. Physicists have started using the term long-period radio transients for them. What produces them is officially unknown. And everyone that has been cataloged is closer to home than the FRBs, closer even than most pulsars we routinely study. Whatever these are, they live with us. Number 2. The peritons. The signals that mimicked fast radio bursts so perfectly that for 6 years no one realized what they actually were. And now that we know, the implication is worse. Between 1998 and 2015, the Parkes Radio Telescope in Australia, the same one that had recorded the Lorimer Burst, kept detecting strange signals that looked, at first glance, like fast radio bursts. They were short, they were bright, they swept across frequencies, but something about them was off. The dispersion pattern was slightly wrong. They tended to arrive during working hours, and they were catalogued with careful astronomer humor as peritons, after a mythical Greek creature that casts a human shadow. For years, the peritons drove astronomers half mad. They were similar enough to FRBs to contaminate the dataset. They were different enough to suggest that something local was mimicking a genuine astrophysical phenomenon. Papers were published. Theories were proposed. Some researchers argued the peritons were atmospheric. Others argued they were secondary effects of nearby electronics. Nobody could pin it down. In 2015, a team led by Emily Petroff finally figured it out. The source of the peritons was the microwave oven in the observatory's staff kitchen. If someone opened the microwave door before its cycle finished, the magnetron produced a brief burst of radio energy that leaked into the telescope's receiver and looked, for a millisecond, exactly like a fast radio burst from 3 billion light-years away. That would be a funny story if it stopped there, but the implication is deeply unsettling for the field. The Parkes telescope was, at the time, one of the most sensitive and best monitored radio telescopes on Earth. Its staff included some of the most experienced radio astronomers in the world. And for nearly 2 decades, the instrument was fooled, repeatedly, by a piece of consumer kitchen equipment operating 100 meters away. If a microwave oven can produce something that mimics a cosmic signal that closely, then the question every radio observatory must now confront is how many of the other signals they have flagged as unexplained are also mundane. And the flip side, how many mundane detections have been discarded as interference when they were actually cosmic? The periton story means that our confidence in the entire archive is lower than we would like. Every unexplained signal from the last 50 years now carries a hidden asterisk. And the specific question of which historical signals might be peritons in disguise, and which might have been genuine detections dismissed as noise, is one the field has openly admitted it may never be able to fully answer. Number 1. FRB 202-001-20E, the burst that came from a place where nothing should exist, and physics has quietly stopped trying to explain it. In April 2020, the CHIME radio telescope in British Columbia, Canada, detected a fast radio burst that was different from every previous FRB in one crucial way. It was located and localized precisely, and when astronomers followed up on the coordinates, what they found broke the standard model of how these bursts are supposed to work. The formal designation is FRB 2020012OE, and it was eventually associated with a globular cluster in the direction of the M81 galaxy, roughly 12 million light-years away. That sounds ordinary. It is not. The globular cluster it appears to originate from is an ancient, dead stellar system. Its stars are billions of years old. There are essentially no young neutron stars, no fresh magnetars, no active astrophysical machinery of the kind that every existing FRB model requires as a source. In other words, the leading theoretical model for what produces fast radio bursts requires a young, ultra-magnetized neutron star. FRB 2020012OE is coming from a place where such a star, according to our models of stellar evolution, should not exist. And it is a repeater, so whatever produced the burst is still there, still doing it, and still surviving between bursts, in a stellar graveyard where it should not be. The proposed solutions get uncomfortable quickly. One serious paper proposed that the source might be a compact object formed through white dwarf collisions, a mechanism that has never been directly observed and is theoretically extreme. Another proposed a primordial black hole, a hypothetical relic from the earliest moments of the universe, which if confirmed would rewrite modern cosmology. A third, more speculative line of thinking argues the burst could be evidence of exotic physics, some form of matter or energy conversion that current models simply do not include. None of these are accepted. All of them are on the table. And every one of them requires our current understanding of extreme astrophysics to be incomplete in a way that most physicists are, for professional reasons, reluctant to publicly acknowledge. Because if FRB 2020012OE is coming from an ancient globular cluster with no viable source object, then either the cluster contains something we cannot see, or the physics producing FRBs is not what we think it is, or CA, and this is the possibility that appears in careful, hedged language in the literature and nowhere else. The burst is not being produced by a naturally occurring process at all. That last possibility has not been proven. It has not been formally proposed as a leading hypothesis by any major team. But it is the possibility that, once you have read the papers and looked at the data, sits at the back of the room and refuses to leave, because the natural explanations keep breaking against the observations, and because the alternative, however uncomfortable, keeps fitting the numbers. 12 million light-years from Earth, in a dead cluster of old stars where nothing should be flashing, something is flashing, repeatedly, on schedule, and every telescope we point at it agrees that whatever is there, it is real, and it is speaking, and it will still be speaking long after we have stopped listening. If you want to see more videos like this, subscribe, like the video, and share with a loyal friend.